find the remaining trigonometric functions of t, given that tangent of t is negative 12 over 5 and sine of t is positive. What is t? We don't know, and we don't need to know that for this problem. Sine of t is negative 12 over 5, and sine of t is defined as y over x of the coordinate of the terminal points, and this is given as negative 12 over 5. Before we make y equals negative 12 and x equals 5, we must determine which quadrant t lies in. With the first piece of information, where tangent is negative 12 over 5, we know that t has to be either in the second quadrant, where x is negative and y is positive. That is what would make tangent negative, or in the fourth quadrant, where x is positive and y is negative, and that would make the ratio negative. T cannot be in the first quadrant because in the first quadrant, x is positive and y is positive. It would make the ratio y over x positive. And t cannot be in the third quadrant because in the third quadrant, the sign of x and y are both negative. Negative over negative would give us a positive, not a negative. And so, with the first piece of information, tangent of t is negative, we know that t has to be in the second or the fourth quadrant. And so, with the second piece of information, what does it have to do with this problem? Tangent of t is defined to be the y coordinate, and this second information say that y is positive. Y is positive in the first quadrant and in the second quadrant only. And so, the intersection of these two restrictions, if you will, is the second quadrant. We conclude that t is in the second quadrant. And so, if t is in the second quadrant, x has to be negative and y has to be positive. We cannot make y equals negative 12 because y has to be positive, but that's okay. A quick fix is to rewrite this as 12 over negative 5. Negative 12 over 5 is 12 over negative 5. We need to do this so that x is negative and y is positive. From here, we can say x is negative 5 and y is 12. Unfortunately, this is not a point on the unit circle because negative 5 squared plus 12 squared is not 1, so we cannot use it. Alternatively, tangent of t is defined as sine of t over cosine of t. And so, the ratio given is 12 over negative 5. But we cannot make cosine of t equals negative 5 or sine of t equals 12. Because, so far, we define sine and cosine using the unit circle. And on the unit circle, x has to be less than 1 and y has to be less than 1 or greater than or equal to negative 1. And so, this is also not useful. In the future, we might save these and do something about these, but for now, we will have to shelve it. So what do? We have the identity tangent squared of t plus 1 equals secant squared of t. So we will use this. Tangent is given as negative 12 over 5 squared it plus 1 equals secant squared of t. Secant squared of t is therefore 144 over 25 plus 1, which is 144 over 25 plus 25 over 25. This is 169 over 25. And so secant squared of t is 169 over 25. Secant of t is plus or minus the square root of 169 over 25, or 13 over 5. But remember, we already determined that t is in the second quadrant, and in the second quadrant, secant is negative, so secant of t is negative 13 over 5. If secant of t is negative 13 over 5, the reciprocal of secant of t is cosine of t. Cosine of t is negative 5 over 13. Also, if tangent of t is negative 12 over 5, then cotangent of t is the reciprocal, which is negative 5 over 12. So far, we have 4 trigonometric functions for t already. The 2 remaining trigonometric functions are sine of t and cosecant of t. If we found sine of t, then we have cosecant of t, since cosecant of t is the reciprocal of sine. To find sine of t, we would use the identity cosine squared of t plus sine squared of t equals 1. We already know cosine of t, which is negative 5 over 13, and we square this, plus sine squared of t equals 1. Negative 5 squared is 25, and 13 squared is 169, plus sine squared of t equals 1. Sine squared of t equals 1 minus 25 over 169, and so sine squared of t is 169 over 169, which is 1, minus 25 over 169, and this is 144 over 169. And so sine squared of t is 144 over 169. Sine of t is a plus or minus the square root of 144 over 169, which is 12 over 13, positive or negative. But since t is in the second quadrant, sine of t is positive, so we conclude that sine of t is a positive 12 over 13. If sine of t is 12 over 13, cosecant of t is 13 over 12. We now have all 6 trigonometric functions.